when I am developing my vision of a new product, if I'm listening to live music, I'll think about that sound and memorize that sound, and then try to think of an architecture that can support and create that kind of sound.
Sophia has a sound that no one was complaining about. But we knew through our testing and experimentation that we could add more without taking away the inherent beauty and musicality of the system.
So I create an architecture and come up with some designs. Sometimes I come up with clay models. Very often they're sketches and so forth.
So with Sophia 3, I think our major issue was retaining the beauty of the sonic presentation while adding this sense of size and scale and detail and low frequency control and cabinet resonant control.
And then I'm very fortunate to have a team here and we'll sit down and I'll go over some of the sketches and the ideas and so forth. And Blake immediately starts putting it into his computer.
And using our CAD system, I will design up several different versions of what he's come to me with. This is one in particular that we started looking at, and we kind of have a little bit of fun and get a little crazy with the ideas sometimes. It kind of morphs and we get a little more refined. And you can see in this model here we've refined some of the lines, looked at common features between Sophia 2 that we wanted to try and incorporate in Sophia 3 to give it that resemblance. That's where we ended up. From there, we will actually take that, send it to another location that has the ability to print that model in 3D. So we'll actually get a scaled down representation of what that product is going to look like. And so from there, we generate the machine code, actually cut parts to do our first prototype, get that assembled and built, and that becomes the first version of the product that we use to begin the crossover development.
Vern, our director of engineering, he's working on the electrical and acoustical properties of the crossover.
I will be looking for drivers, and I'll also be designing crossovers, and then begin to simulate in a virtual concept the crossover. That simulation program allows me to play with the components to simulate a driver, a box, and also the crossover in front of it. From that initial frequency display, I can then change the component values to tailor the presented frequency response until it matches what I would anticipate a good starting point to allow Dave Wilson to start the listening process.
Sophia 1 was the first of our prototypes to go through this room number 2, this boot camp room, this torture chamber, if you will. Typically, when the first prototype goes into that room, a prototype where the computer is saying, look, this is really a well-done speaker. You put it in there and it just sounds terrible.
Some of the challenges that we had in the Sophia 3 project dealt with changing some of the geometries of the speaker enclosure. The volumes that each of the drivers sees changed. Now, the other aspect that we had that also changed was integrating the new Wilson Audio mid-range into this project. Both of those created some characteristics that, in simulating the project beforehand, didn't show up.
The good thing about the discipline that room number 2 demands is that it will not give you a false, pretty sound. And we use spectral power amplifier in there. Now, that's not a bad sounding amplifier, that's an extremely linear amplifier. There's no artificial sweeteners in that amplifier. And so it doesn't lie to you about it.
I was then able to take what we had encountered back into the computer and do a few changes, and then found a whole new direction in which the project was able to go. And as a result of that, we were able to integrate very easily the Wilson Audio mid-range into this project. Being able to develop our own proprietary models, the physical starting point of a prototype becomes many months ahead of what it would have been without the use of a computer.
By the time you finish in room number 2, it's actually sounding pretty good in that room. And I will confess to occasionally being tempted to say, wow, maybe it's done, but then no, we have a protocol, we have a system here. And then we take it into room number 3, which is a very quiet room. It has an extraordinarily low noise floor. Speakers don't tend to sound beautiful in that room. It's a tool. You put that room on like a pair of headphones. And then it goes up to another demanding room, but ironically it's a room that sounds fabulous, but it doesn't measure that well with a single loudspeaker with a typical long microphone distance. And that's the music room up at the house. And there we will throw a variety of amplifiers at it. We have vacuum tube solid state amplifiers. We've got, quite a range of amplifiers there. That's always a revelation to measure it there. And just when you think you've got it nailed down, you find warts in it that need to be, surgically excised.
The concept of creating a testing protocol allows him to go from experiment to getting the answer or the truth that he was seeking from one experiment and moving right to the other and finding out the truth of that experiment, and then taking the results of those and implementing them in our product. So in turn, what that's done is it's helped with our development time to be a little bit quicker and for us to implement more innovations per product in a shorter amount of time.
We're a very compatible group. We have compatible strengths and contrasting weaknesses so that we can really get things done. And we're all passionately dedicated to creating this this vision of sound.